Hi, this is Steve Scully. I'm reading from my book, The Instruction Manual, as it is written in the cosmos, picking up from the last video. This one, so we'll just start off. We're on section E of chapter 1, the sharpened point of scientific progress. Throughout the history of scientific progress, universal laws have become more apparent. What was broad, nondescript, and localized opinion has changed over time to be specific, elaborate, and global consensus. This process functions like the sharpening of a point of an object such as a pencil. The tip of the point is akin to the most foundational bases of a scientific hypothesis. The layers behind the tip branch off wider and wider, carrying more and more substance. At first, the tip was like an unsharpened pencil, all things interpreted to have their own causes. Over time, as observations were seen to have more fundamental shared root causes, the tip was sharpened to be explained by fewer and fewer underlying mechanics. Not only has the sharpness increased, but the evidence behind it has increased both in volume and in detail. This increase in detail acts to give actual density to the material upon which the sharpened point is built, and the increase in volume functions as a growth of the different components of which the material is composed, alike to making the pencil larger and stronger. For example, adding math increased the volume, and adding more detailed math increased the density of the material the sharpened point is built upon. The sharpest point with the most weight and density behind it will shatter all paradigms. When we look at current scientific models, the sharpness of the point would be akin to the model's base requirements, the weight being the evidence behind it, and its density being the thoroughness of the evidence. If a model does not incorporate known observations, however, it contains holes that result in weaknesses in the overall system. If it does not have a sharpened point, it is dull and unable to penetrate these openings in other models. Like an aluminum arrow shot against a stainless steel beam, dull, low weight, and low density scientific interpretations crumble when they encounter a more grounded, sharpened, all encompassing, and detailed description of the nature of reality. In the case of current models, the sharpness appears high but is comparatively low. For example, the Big Bang model requires the existence of four fundamental forces of nature: expansion of space, and dark energy, to say the least. Quantum mechanics claims the existence of several fundamental particles, four fundamental forces, and expansion of space and dark energy persist. General relativity, much the same, requires largely these same elements. The number of foundational elements required in a model can be considered its sharpness factor. When there are countless objects in the cosmos, the reduction of the cause of them all to such a small list of elements acts as a sharpening of the point. However, these remain dull next to a point containing only one element. The points are not as sharp as they can be. Similarly, each model has many observations behind them in several specific areas that assist in developing the weight and density of the material. In the case of quantum mechanics, for example, it has the double slit experiment as a major component, and its many, many particular experiments as a large degree of density. Each model, however, has its limits. It knows of outside observations, but they are unable to be incorporated into the model. As a result, they are heavy and dense, but not as heavy and dense as they can be. As physics focuses further and further on root causes of universal observations, these factors are the most significant primary consideration in the validity of a model. If the sharpness of the model does not increase, then the model is definitively invalid. If the weight of the model does not increase, then the model is definitively invalid. If the density of the model does not increase, then the model is definitively invalid. An example of this is the theorized fifth fundamental force. Other current models list 4, and so already they are more specific. Therefore, a fifth fundamental force is invalid. Not to say that 4 is any better than 5. Purely from a sharpness factor perspective, the sharpest possible tip is with one single element, as when there are 0 elements, it is no longer part of the object. In other words, the final step in the sharpening of our scientific proverbial pencil is to demonstrate how one single root cause produces all things. This would have a sharpness factor of 1 while having the weight and density of all observations behind it. In such an instance, the model would be a description of truth. Section F, the limitations of technology. With the human eye, we can perceive a vast array of the cosmos, from minute detail of the world around us all the way up through stars and even the dusty appearance of distant galaxies. We can see much of our surroundings. However, there are limitations to what we can see. To expand how far we can see, we do this by looking beyond our limits of perception in both directions, big and small. For the big, this is done with, for example, telescopes. And for the small, this is done with, for example, microscopes. This increases our ability to see into the depths of the microcosm and macrocosm drastically. We make the mistake then of thinking that the improvement in what we can see is so vast that we see to the very limits of reality. In truth, we see to the very limits of our instruments. No different than the limitations of the human eye, technology has this same intrinsic inability to see beyond. For us, these limitations are within the depths of infinity. No matter how deep we manage to peer into infinity, there will always be a limit to how far we can see beyond which there is infinitely more, regardless of the lens through which we perceive it. The universe is the manifestation of infinity, and no instrumentation can ever pierce its depths. Let's just jump into the next section, section G, what classical mechanics was missing. In Sir Isaac Newton's Principia, he outlined laws that the universe functions under, known as the laws of motion and the law of gravity. The laws of motion are the first law of motion. An object either remains at rest or continues to move at a constant velocity unless acted upon by an outside force. The second law of motion, force is equal to mass times acceleration. And the third law of motion, when one body exerts force on a second body, the second body simultaneously exerts a force equal in magnitude but opposite in direction on the first body. And then the law of gravity is such that a body attracts every other body in the universe using a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So with all the observations we have today, these laws are applicable to each and every one. What the model is missing, however, is 2 things regarding how and where they apply. The first is that the universe is infinite. There is no end to how large and how small masses in the universe can be. And the second is that sufficiently small particles can travel through sufficiently large particles. From this, the fundamentals of physics of the universe as a whole can be fully understood. For example, Any given particle can be divided into smaller particles. Like the atoms of the Earth is divisible into smaller particles. So too are all particles divisible in this way. The atoms themselves are divisible into smaller particles in the same way, which are divisible further ad infinitum. Just the same, all particles are combined into larger particles. All that we see in the observable universe is but a small portion of a larger particle. This is why small particles can travel through large particles, because every particle is made up of smaller and smaller particles. This analysis leads to the universal principle of natural philosophy, which is discussed herein. This title is given to the theory because it uses the laws described by Isaac Newton in the mathematical principles of natural philosophy to deduce the singular fundamental universal principle, where principle is defined as a fundamental, primary, or general law or truth from which others are derived, which serves as the basis for interpreting truth. Moreover, the title highlights the importance of natural philosophy in the process, which is a necessary component for logical deduction of how the universe functions. The term universal is in reference to the universality of the fundamental principle where the theory arrives. Importantly, though it is a theory in appearance, this does not preclude it from being actual description of the underlying mechanics of the universe. There is a critical difference between a theory and a principle. A theory is one which, in its nature, is not proven. In this case, the most accurate label to ascribe to the theory presented herein is not theory, but rather the universal principle. This is because, regardless of outside perception of it as just a theory, it is built upon all evidence, as will be elaborated upon herein, having infinite weight and density behind it, and it is sharpened to the finest of points. For it shows that from one all arises. And that's the end of chapter 1. Next chapter is chapter 2, the universal principle of natural philosophy, and I will start that one in the next video. Thanks for stopping by.